Good morning, sir.
Yeah, hello. Very good morning to you all.
Good morning, sir.
A very good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Yeah, good morning. So kindly wait for another few minutes till we start the session. We have only the participants joining in.
Sir, I have a doubt. I also asked that doubt last class, but
Okay.
you didn't tell, sir.
Okay. Yeah, so this is Maunika. Who is speaking? Maunika or Divya? Who is it? Yeah, please repeat the question that you had asked last time.
Sir, Vedic square, I have a doubt, sir. I can't understand that one.
Okay. So what we will do is we'll take up this question towards the end of the lecture because we are going to begin in a few minutes. So I'll be able to explain to you in detail towards the end. Is that
Okay,
fine?
sir.
Okay. Right. So we'll begin in another minute. We have more participants joining in. So today I will revise some of the topics that we did yesterday, and we shall
morning,
do
sir.
more
Good morning, sir.
multiplication.
Good
Okay?
morning, sir.
Yeah, very good morning. So from this point, I'm going to
Good
mute
morning,
you
sir.
all. So you can post your questions, if any, in the chat box. I'll have a look into the chat box. Okay. So I think we are ready to start. So we have still participants coming in. So I'll just make a warm up of what we are going to do today. So in yesterday's class, we have seen about multiplication, and in particular, multiplication close to the base. So today, what we are going to see is more details of this method that we learned yesterday. So yesterday, what we learned is what is called as the base of a number. So base is usually a multiple of 10. And the use of this base is that you can see the difference of a number from the base and identify what are the ending digits and what are the beginning digits. So in this way, you can do numbers very close to the base. For example, numbers close to the base 10 will be something like 8 or 7. Numbers close to the base 100 would be something like 98, 90, 91, etc. So we can easily compute these multiplications without worrying too much about the carries. So yesterday we had a lot of newcomers. So if you have seen some of the older lectures, you will have noticed that there is a large importance being given to what is called as the digit sum. So everyone has to go and revise this topic of digit sum. It is going to be very useful while we deal with other topics in Vedic mathematics. So today we are going to look into this topic known as magic numbers. We have indeed, I studied about a magic number in one of our previous lectures, and that is the number 11. So coincidentally, the lecture number also is a magic number. So that is 11. So we'll begin with a little bit of warm up from what we did yesterday. So yesterday we had dealt with this multiplication close to the base. So today what we are going to see is what is actually happening while we do multiplication close to the base. So let us take this example of 88 multiplied by 98. So 88 and 98 both are close to the number 100, which is the base. So I'm going to write how much deficient is each number. 88 is minus 12 deficient from 100 and 98 is minus 2 deficient from the 100. So you can write the solution to this as two parts. You draw a line like this, and towards the right of the line you will multiply minus 12 and minus 2 to get 24. Okay. Now what you should do is you should cross addition. You should have to apply cross addition. You can add minus 2 to 88 to get 86. So this is the answer to this, 8624. Now let us see what is the actual step that is happening while we do this shortcut method. So here is what is actually happening. So I'll explain line by line. So we write 88 times 98. 98 is written as 100 minus 2. Isn't it right? It is minus 2 away from 100. Now what we do is you do 88 into 100. This is the distributive law of multiplication. 88 into 100 and 88 into minus 2. So that becomes 8800 minus 88 times 2. Now next what we are going to do is we are going to split this number 88 as 100 minus 12. So you can see 100 minus 12. And to each of these numbers we are going to multiply 2. Okay. So what we get here is 200 from the first part and 24 from the second part. Now you distribute the minus sign inside, you will get 8800 minus 200 plus 24. Now let us do this particular calculation using figures. So here I have plotted this figure. So this is a square. This is a square of side 100. So we have two numbers to multiply. The first number is 98 and the second number is 88. So 88 is deficient by 12, 98 is deficient by 2. Now what we have done here is first we have multiplied 88 into 100. So we'll get a rectangle of this area, 8800. Why is it 8800? Because 88 is multiplied by 100. This entire length of the rectangle is 100. Okay. Now what we have done is we get a 200. From where we are getting this 200? Let us see this in the figure. This 200 is nothing but it is this side, which is 100, multiplied by the deficiency of 98, which is 2. So from 8800 we have to deduct this 200, but then we have to add a number. What is that added number? That is 24. What does that represent in the figure? This 24 is this rectangle. How do you get 24 here? That is quite simple. This side is 12 and this side is 2. So 12 into 2, which is exactly the deficiency multiplied, where we did the second part of the answer coming from 12 times 2. So this set of figures is explaining to you how we are getting this particular solution to the multiplication near the base in more detail. But if you do not understand this clearly, do not worry. You can skip this particular slide. That is also fine if you do not understand this concept properly. But the entire idea is about inclusion and exclusion. So in mathematics, there is this principle called as inclusion and exclusion. So let me just write down what does that mean. So inclusion means you are going to add certain terms to the actual answer. The actual answer required is in this yellow box, but you have added an additional term here, isn't it? This rectangle over here is not the actual answer you required, but in order to simplify the steps, you are including some additional rectangles. So that is known as inclusion. And you are also excluding. Where did we exclude? We are excluding this 200. So exclusion is something like you are subtracting some unwanted parts. We have removed this unwanted part, but along with the unwanted part, we have removed some more. So that is why we had to add this 24 at the end. So this particular kind of detail will help you understand more into the simplicity of the steps that we have performed yesterday. Now let us go into some of the problems. So today we are going to see larger numbers, multiplication of numbers that are greater than 100. So this example was done yesterday. So I want all of you to put your answer on the chat box. I'll give you around 20 seconds to see what answers are you giving. Okay, I'll give a clue. So 103 is 3 greater than 100. 104 is 4 greater than 100. Yes, I can see the answers from Maunika. Yes. Vinay, very good. Yes, so let us see once again how we can do this. So what we can do is you multiply 13 times 4. 13 times 4 is, 3 times 4. 3 multiplied by 4 is 12. And you have to do cross addition. So which is 103 plus 4, which is 107. So 10712 is the answer. So I can see more answers coming, Divyansh and Hemachandra. So congrats for all those students who have got this correctly. Now let us see the next example. So I want others also to join who are in the class. So can you find what is the answer to 123 times 102? So this can be written as plus 23. This can be written as plus 2. This is quite direct. This is quite direct. I don't see any answers yet. Yes, Maunika, very good. So let us see if the answer that you have answered is correct. Yes, I can see more answers from Shibani, Suhas, Vinay, Chinmay, Abhiram, and Krish. Let us verify. So what is going to be the number towards the right? It is going to be 23 multiplied by 2, which is 46. And what is the number towards the left? That is the cross addition. So while you do cross addition, you just have to pick up the smallest number here. That is the easiest one. So it is going to be 12546. Now, till now, we have not experienced a carry. So let us see what happens if a carry is also there. Let us see if this example has a carry. So I want all the students to participate in the chat and mention what is the answer. So here I'll directly write the answer as 33 and cross addition, this is 114. So you can see the simplicity of the steps. Okay. So let us do some practice. Let us do the last one over here. So this will have a carry. Okay, so what is the greater part of 162? It is plus 62. The greater part of 102 is plus 2. So what is it going to be? 62 multiplied by 2 is 134. But remember, the base is 100. The base here is 100. So you have to write it. It is 62 multiplied by 2, which is 24, 124. So 1 is written as a carry, and you do cross addition. So it's 164. The answer is going to be 16524. Okay, so I can see a lot of answers coming in. So thanks to Chandana, Maunika, Krish, and Suhas. So let us go ahead again with some bigger numbers. Okay. So what is 568 multiplied by 998? So 568 is closer to the base of 1000. Now the base has changed. In the earlier problems, the base was 100. Here, the base is 1000. So how do you find the difference of 568 from 1000? Can anyone say what is the particular sutra that we are going to use? What is the particular sutra that we are going to use? Yes, it is going to be all from 9th and the last from 10. So all from 9th and last from 10 for 568 will be 4, 3, 2. And there is a negative sign because you are doing how much deficient is it from 1000. And of course, 998 is minus 2. Now, if you multiply this, you will get 864. And if you do cross addition, which is 568 minus 2, you are going to get 566. Yes, I can see a lot of answers coming in. Komal Preet, Yashwant Reddy, Suhas, Krish. Very good. So what we did here is to find what is the deficiency of 568 from 1000, and that number we are getting at 432. Now let us go for one more example. So this example has been solved yesterday, but this time I want you to try, all of you to try this. This has been done yesterday. So this is to the base 1 lakh. So if you recall the example yesterday, you might see it is 1 followed by 5 zeros because this is a 5-digit number. Yeah, so somebody is asking to explain again. So in the meantime, I explained the earlier problem. You can solve this particular problem and post your answer on the chat box. Okay. So let us see this problem once again. So this has been asked by Pramil. So let me explain this again. So 568 multiplied by 998. So both these numbers are 3-digit numbers. Do you agree? The number 568 and 998 are both 3-digit numbers. So 3-digit numbers are closest to the base of 1000. 1000 is 1 followed by 3 zeros. Any 3-digit number is close to the base of 1000. So to do multiplication close to the base, you have to find how much each number is deficient from 1000. So what you have to find is 1000 minus what number is going to be 568. So in order to do that, there is a simple technique. What is that technique? That is called as all from 9s and last from 10. Now, if you are new to this class, you will not be aware of this technique. So I'm explaining for all the new students once again. So what you have to do is just write 9, 9 and 10. All the numbers you write 9 except for the last number. So 9 minus 5 is 4, 9 minus 6 is 3, and 10 minus 8 is 2. So you get 432. That is the deficiency of the number 568 from 1000. Now the deficiency of 998 from 1000 is straightforward. That is minus 2. So that is 864 if you multiply together. Now this number you will write on the right hand side of this line. The number towards the left hand side is 568 minus 2, which is 566. So that is why this answer. So I think Pramil, now your problem is solved. Now let us go to the answer of this number. So I can see some answers coming in. Let me do it for your sake. So what you're going to do is all from 9s and the last from 10. So I'm going to write the numbers 9999 and the last number I'm going to write it as 10. So the deficiency of this number from 1 lakh is nothing but 31223. And the deficiency of this number is going to be 3. So if you multiply these two numbers, what you're going to get is 96639. And what is the left hand side? It is going to be 68,777 minus 3. That is 68,774. Yes. So some of you have got these answers right. You can verify for yourself. That's very nice. Now, I will do one more from the practice set for you. The remaining you can try it at home. Let me do the second one over here. So the second one again is a 5-digit number. So what is the base that you have to apply? So what is the base that you have to apply? Pramil, if you are there, can you put that in the chat box? Yes, the base that we have to apply is 10 power 5. Yes, that is very right. So 10 power 5 minus 90909. What is that going to be? 10 power 5 minus 90909. We are going to write it as all from 9s and the last from 10. So this is 9999 and 10. So this number is deficient from 1 lakh by 0. The first number is 0, second number is 9, third is again 0, then you have 9, and the last one is 1. So the answer is 9091 less than 10 power 5. And this is minus 6. So you have to do minus 6 multiplied by this number. Now there is an easier way of doing this. That is by number split. You can split here. So 6 multiplied by 1 is 6. 6 multiplied by 09 is 36. And again, 6 multiplied by 9 is 36. So this is going to be the last ending digit. So you can do 36366. And the remaining part is 90909 minus 6. That is 90903. Are you getting the same answer? Can somebody confirm? I don't see anybody has answered. You can verify for yourself. Yeah, Krish has answered. Okay. Very good, Maunika. But you have to check the answer once again, Maunika. Komal Preet, your answer is correct. So I hope no one is using a calculator. So do not use a calculator in this class because the whole aim of this class is going to be to avoid the calculator. Okay. So now I'm going to show you a video on how easy the method of Vedic multiplication is. So kindly watch this video. I'll show for around 5 minutes. So hope you are able to see the screen. So if you are able to see the screen, kindly write yes in the chat box. Okay, so I'm going to start this video streaming. So hope you can also.
Well, good afternoon, ladies and gentlemen. My name is Art Benjamin, and I am a mathematician. What that means is I combine my loves of math, or I should say maths, and magic to do what I call mathemagics. But before I get started, I've got a quick question for the audience. By any chance, did anyone here in the audience happen to bring with them this afternoon a calculator? If you have one, perhaps on your phone or somewhere, and you're pretty comfortable using it, raise your hand. I'll need a couple of people to help me out here. I see 1, 2, and perhaps one more. 3. With the 3 of you, bring out your calculators and join me up here on stage, and let's give these volunteers a nice round of applause. Come on up. Great. Over on this side, please. Awesome. Now, since I have not had the chance to work with these calculators, I need to make sure that they are all working properly. Would somebody get us started by giving us a 2-digit number, please? How about a 2-digit number? Just yell one out. Oh, so, okay, that's fine, 74. And another, how about another 2-digit number? How about on this side? 39. Multiply 74 times 39 on the calculator. Make sure you get 2,886, or the calculators are not working. Do each of you get 2,886? Give them a round of applause. Now, I noticed that took some of us a little bit of time to get the answer. That's okay. I'll give you a shortcut for multiplying even faster on the calculator. There's something called the square of a number, which most of you know is taking a number and multiplying it by itself. For instance, 5 squared would be 25. 6 squared would be 36. 73 squared would be something else. Yeah. So now on most of these calculators, they have little shortcut buttons that allow you to square numbers even faster. What I'm going to try and do is to square, and you might test it, make sure you can square 5 or 6 with it. But what I'm going to try and do is to square in my head 3 2-digit numbers faster than they can do on their calculators, even using the shortcut method. What I'll ask is 3 people, how about in the third row here, 1, 2, 3, each yell out a 2-digit number. And if you would square the first one, the second, and the third one, I will try and race you to the answer. So quickly, a 2-digit number, please. 24, great, next. What was that? 98, and one more. 26. Would you call out your answers, please? 576, 9,604, 676. Give them a round of applause. Let me try to take this one step further. I'm going to try to square some 3-digit numbers this time. I won't even write these down. I'll just call them out as they're called out to me. Anyone at all call out a 3-digit number? Anyone on our panel verify the answer? Now, if I get the answer right, give me a big thumbs up. If I make a mistake, let me know and I'll try and fix it. A 3-digit number, anyone? 576 is 331,776. Yes, good. How about another 3-digit number? Sir, a 3-digit number. 103 is 10,609, way too easy. Another 3-digit number, please. 125 is 15,625, but that's 5 to the 6th power, so that was easy too. How about another 3-digit number, sir? 985 is 970,225. Yes, thumbs up if it's right. One more 3-digit number, sir. Ooh, 926 is 857,476. Thank you very much.
Yeah, so hope you enjoyed this video. So the whole goal was to show you can calculate all these on head. So if you have good practice. So the whole idea is not to do something like what he has done, but the entire idea is to fast up your calculation a little bit more than what you actually do right now. So, okay. So let us go ahead. So is the audio clear? I want some response from students. If you can hear my audio, kindly write yes on the chat box, because a few students are saying that there is some voice issue. Okay, so Krish has answered yes. Yeah, so Bharati, you don't see the audio. Do you get the audio? Okay, most of them have said yes, so it will be some issue at your end. So kindly check the audio at your end. Bharati and Nikhil, kindly check check the audio at your end. Okay. So we'll move ahead with some more multiplication. This time we'll do a little bit different ones. We are going to deal with magic numbers. So some of these magic numbers are in the form of 9 multiple. So we'll see numbers like 9, 99, 999. So if you go to buy some item, most often you will see the price is something like 499 or 999, etc. So if you're getting a couple of these items or more of these items, you will have to do these multiplications, isn't it? So we are going to do first multiplication by 9 and going to see some tricks how you can make these multiplications even faster. So let us see. The first example is way too easy, that is 7 times 9. But this time I'm going to explain you a rule or a tip to make this multiplication much more easier. So the first thing that you have to do is you consider this number 7 and you minus 1. That is 7 minus 1. This you keep aside. And after doing this, what you have to do is this number is 6. What you can do now is do all from 9 and last from 10 of the number 7. So what is it going to be? There is only a single digit, so you have to do 10 minus 7, that is 3. So the answer is going to be 63. Let us take a bigger number now. I'm going to multiply 54 times 9, for instance. So what you should do is 53 you can write, 1 less, and all from 9 and last from 10. So what you can do is you can put this as 4, but there is a carry. So 4 and all from 9 and last from 10. So this is 4, 6 written like this. So what is this going to be? Is it going to be right? So unfortunately, you will not get the answer here because you are multiplying a 2-digit number with a single digit here. So I'll explain in a minute how you can actually do this in an efficient manner. So let me consider 54. Now what I'm going to see, it is 2 digits. Now you separate this number 54 as 5, 4 and a 0 at the end. So the 0 is required. Now what you have to do is 54 into 9, you are not considering the 0. So 54 into 9 is going to be 4 minus 5, which is what? 1 bar. And 0 minus 4, which is going to be what? 4 bar. And the first number you are going to put as it is, which is 5. So it is 5, 1 bar, 4 bar. Some of the students might realize this. This is a bar number. So how do you do this? This is 500 minus 14, which is what? 486. There was another easier method to do this also. You write 9 as 10 minus 1 and do 54 into 10, which is 540. So 540 minus 54. That will also result in the same answer of 486. So whenever you are doing 2-digit multiplication with a number 9, you have to apply this particular rule. I will explain in more detail with this example. So I'm going to do 73 multiplied by 9. So what you have to do is write 73 as 730 and square, put a square around the 73 to indicate that the 0 is outside. Now do the rule. The rule says the first digit that you should write is the first digit of the number 73. The second digit is 3 minus 7. But 3 minus 7 is a bar number, which is 4 bar. And the third is 0 minus 3, which is 3 bar. So this is going to be 700 minus 43. This is going to be 657. You can verify for yourself. Let us do a bigger number now. This time it is 118 multiplied by 9. So here what we'll do is write 118, put a 0 outside the range. And what we are going to do is the following. So the first number of 118 is 1 itself. Put it as it is. Then you do 1 minus 1. The second digit minus the first, which is 0. Then do the third minus the second, which is 8 minus 1, which is 7. And the last is 0 minus 8, which is 8 bar. Now, what is this answer going to be? Can anyone reply on chat? What is this number 1078? If you have learned the particular concept of bar numbers, you will be able to write what is the bar number representation corresponding to 1078. Yes, I can see Rajesh has given the correct answer. It is 1062. And Suhas, Krish, Komalpreet, Jaya. Okay, very good. So I'll do one more example for you. This time it's a 4-digit number. So what you have to do is the following. 1041, you will put as it is and put a 0 at the end and put a square box around 1041. What we are going to do is the same rule. You have to put 1 as it is. Then do 0 minus 1. 0 minus 1 is 1 bar. Then do 4 minus 0, which is 4. 1 minus 4, which is 3 bar. And 0 minus 1, which is 1 bar. Now, here is a question for you. What is the equivalent number representation of 1, 1 bar, 4, 3 bar, and 1? The answer is quite direct if you know all from 9s and last from 10. So let me give you the answer. So this 1 is going to be carried forward because this is a deficient number. And this deficiency is by 9. So this is going to be 9, 4. But again, 4 is going to become 3 because there is a deficiency in the next two numbers. And you can do all from 9s, last from 10. You get 9369. So the answer is going to be 9369. Okay, somebody is asking explain bar numbers. So this is a concept that we have learned from previous lectures. So I'll just briefly explain what is the concept of bar numbers. So consider this particular number. Say I want to write 52. What is 52? 52 is 50 plus 2. And 48 is nothing but 50 minus 2. Okay. So 50 minus 2 is nothing but, you can write it as 5 2 bar. So bar number is just representing this minus sign that we just did. Okay, some people have doubts. So I would like to take these doubts towards the end of the lectures because it might concern many of you. So I don't want to break the lecture as of now. You make this doubt a point on your notebook or on the chat box. I'll take that in the end. So we have more practice questions. This time we are going to do 2 digits with 2 digits. So let me just clear the screen for you so that it is visible. Okay. So we are going to do 73 multiplied by 99. So whenever you get the same number of digits to multiply, you can use this rule. What is the rule? Write one deficient from the number you are given. So we are going to do the number split. You have to write one number on the right side and one number on the left side. So the number that you're going to write on the left side is 1 less than 73, which is 72. And the number that you're going to write on the right hand side is all from 9s and last from 10 corresponding to 73. What is that going to be? That is going to be 27. So the answer to 73 multiplied by 99 is 7227. Let's do one more. This time it is 81 times 99. So 81 minus 1 is 80. And all from 9s, last from 10 is 19. So that is the answer for you. So hope now you have got an idea about how you have to do this. Now let's do 12 multiplied by 99. This is 1, 1, 8, and 8. You can verify for yourself. What is 37 multiplied by 99? Now 37 is a very magical number. I'll explain this after I solve this. So this answer is going to be 36 and 63. So you can verify for yourself whether you're getting the same answer. So what I have applied is the same rule that I was explaining. So somebody did not understand how we should do 7 multiplied by 9. So let me take this example once again. So when you're doing multiplication by 9 or 99 or 999, what you have to do is the following. You subtract the number that you're given with, you minus 1 from it. So you will get 6. The second part to the answer is obtained by doing all from 9s and last from 10. So there is only a single digit 7 here. So you have to subtract from 10. So 10 minus 7 is 3. So this is how you get 63. Similarly, when it is a 2-digit number, I'll explain with 73 multiplied by 99. 73 minus 1 is 72. And the second part is all from 9s and the last from 10s. So hope you have understood this. Let us go to some more bigger calculations. This time I want to introduce this number 1729. Anybody knows what is the significance of the number 1729? Some of you who are experts in quizzing will know. So this is called as the Ramanujan number. You know who is Ramanujan? So Ramanujan is a great Indian mathematician who has worked in the field of number theory. And he has given this number 1729, and he has said that it has a particular pattern. The pattern is like this. It can be expressed as the cube of two numbers in two different ways. And this is the smallest such number that has that property. It is 10 cube plus 7 cube, if I'm not wrong. There is also one more way of writing this. Okay. So we are going to take this Ramanujan number and multiply by 9999. Okay. So what is the rule that we are going to apply? 4-digit number multiplied by a 4-digit number, that is all 9s. So what we are going to do is subtract 1 from 1729. That is the first part, which is 1728. The second part is nothing but all from 9s and last from 10s. So this is going to be 8, 2, 7, and 1. So this Ramanujan number multiplied by 9999 is going to be 1728, 8271. Okay. Now we are going to this current year, which is 2020. What is 2020 multiplied by 9999? I want all of you to write your answer in the chat box. Yeah, kindly try this and write the answer in the chat box. I'll give you exactly 15 seconds to answer. I can see a few answers, but it is not right. I think you are missing a 0 at the end. Akhil, Charanya. Not exactly. Maunika has given an answer, but everyone is giving a different answer. Let us verify for ourselves. So the first part of the answer is going to be, what is it? 2019. It is 1 less than 2020. So if 2020 is the current year, The last year was 2019. Second part of the answer is going to be all from 9s, last from 10. So the easiest way of doing this is write 9 on top of all numbers except the last one. So this is going to be 7, 9, 7, and 10. But this 10 has to be written like this, because this one should go as a carry to the next place. So this answer is going to be 2019 7980. Yes, I can see Krish has answered it correctly. I don't see yet any other correct answers anywhere. Okay. So let us go back to this particular slide. So you can verify this at home once again. Yes, I can see more answers coming in. Okay, good. So for the time being, in the interest of time, I'm going to skip this slide. I'll take this up in the next class. So there is also a property called as proportionally, which has been taken in a previous video. So you can see the previous video to understand what is this Vedic sutra called as proportionality or anurupiyana. So for the time being, let me skip that. So we have some more useful products. This also I'll do it in the next class. I want to especially take up some problems that were present in practice set 4. Some of the students might have solved this, but I wanted to take this especially because this would benefit you. These are word problems. I have explained what is word problems. Word problems are nothing but mathematical concepts being tested in the form of sentences. You are given an idea about the problem in the form of sentences. So we'll solve 4 problems here, and after that I will leave you. After that, I'll take around 20 minutes of question answer session. So what I see is that many of you have doubts, but I am unable to answer them during the lecture. So today I'll wait for another 20 minutes. So it is not compulsory for all of you to sit for these 20 minutes after the lecture, but you wait till these 4 questions are discussed for today. Okay. So we are going to take up this question. There is some confusing set of words: daps, yaps, baps, and daps, something like that. So do not worry about these. Instead of that, just concentrate on the numbers. So we have 42 baps to be found instead of or found in terms of this daps. But here you are given 3 baps is equal to 5 yaps. So how much multiplied by 3 will give you 42? What should you multiply with 3 to get 42? The answer is 14, right? So 14 multiplied by 3 is 42. So you have to do 14 multiplied by 5 to get the number of yaps. So this is going to be how much? 14 into 5. It's quite direct, right? 14 into 5 can be done as 50 plus 20, which is 70. Everyone can answer this. So 42 baps is same as 70 yaps. 70 is obtained by multiplying this by 10. So if you multiply this by 10, you have to multiply here also by 10, which means you will get 42 baps is equal to 40 daps. So 40 is the right answer. Yeah, some of you have answered, but you have written as 8 daps, which is not right. So this is a little bit confusing because of the names. Because of the names, you will get a little bit confused. But take a minute to observe what is the question exactly and try to do in the method that we explained. Let us go to puzzle number 2. So puzzle number 2 is the following. There are 2 numbers which are in the ratio 5:6. So everyone is clear with this idea of 5:6. So 5:6 meaning if you divide a number like 10 divided by 12, the ratio of this number 10 divided by 12 is 5:6. because 2 is the common factor. If you eliminate the common factor, you are going to get this. So 5:6 ratio means the one number is 5 times some unknown x, and the second number is 6 times some unknown x. You are given that the sum of these numbers is 77, which means 5x plus 6x is 77, or x is going to be 7. Now the difference is 6x minus 5x, which is x, which is 7. So I can see a lot of answers. 7. Komal Preet, Shailaja, Suhas. Yes, you have got it right. Somebody is saying Suhas 35, 42. I don't understand what the answer you have written. Abhiram also. Okay. So hope you have understood these two problems. What we have done in the second problem is to call this unknown number as x, and then we have continued. Let us go to this third and interesting problem for you. So what is the units digit of the number 3 raised to the power 2020? So this is the current year. So 3 raised to the power 2020. Anyone knows the answer for this? Okay, don't worry. So what we are going to do is the following. We are going to learn about the multiplication table of 3. How is it? 3 multiplied by 1 is 3. 3 multiplied by 2 is 9. 3 multiplied by, sorry, I missed the 6. So let me just write this as 6, 9. And what is the next number? 12, 15, etc. But what I'm looking for is 3 to the power 1, which is 3. 3 to the power 2, which is equal to 9. 3 to the power 3, which is equal to 27. And 3 to the power 4. What is 27 multiplied by 3? By now you will be able to say. This is 81. Yes. So the units digit of a number is nothing but the number obtained by multiplying the units digit of its factors. So we are going to factorize 2020. 2020 is a very special number. It can be divided by 4. So this can be written as 81 raised to some number. Divide this number by 4, you will get 505. So we know 3 power 4 is 81. So the number 3 power 2020 is going to be 81 to the power of 505. Now any number which is ending in 1 raised to the power of something, that number, that particular power has an answer of the units digit as 1. So this is a very important property. So 1 is the answer. The units digit that corresponds to 3 power 2021 is 1. Now I am going to ask you another question. What is the units digit of the number 3 power 2021? If anybody knows the answer, you can write that in the chat box. So I'll wait for maybe 15 seconds. Yes, Suhas, you are right. That is 3. How did you get 3? Because you know the units digit of 3 power 2020 is 1. Okay. Now we'll do the last problem for today. After that, you are allowed to leave. If you have doubts, you can stay back for the 20 minutes question answer session. So the sum of 2 digits, 2-digit integer of a 2-digit integer is what? 12. And the value of the integer is 13 times the 10th digit. So you have to find the integer. So you have some integer. It's a 2-digit integer. The sum of digits, it's not the digit sum, it's the sum of digits. So you can call this number as x, y. X is in the tens place, y is in the units place. So what you're given is x plus y is 12. Now, the particular number that you're looking for is the number 10 times x plus y. Why I could write this? Because x is in the tens place. So the number you are finding out is 10x plus y. Now this is given to be 13 times the tens digit, which is x. So what you're getting is y equal to 3x. So if y equal to 3x, this implies that 4x is 12 or x is going to be 3. So if x equal to 3, y equal to 9. So the number that you want to find is 39. So these are simple tricks that you can apply, isn't it? So some of you might have understood, some of you who have not understood, I would like to explain this once again in the question answer session. So now we will conclude this lecture. So you will get one puzzle to solve after this lecture in the Practically app. So you can look at around 12:30 or so. I will upload that in the Practically app and you can try and solve this puzzle. There is also a puzzle that was given yesterday. Try to answer it within 1 or 2 days. Okay. So now I will open the floor for questions. Those students who do not have questions may leave the session. So the rule for the question answer session will be you have to raise your hands and I will unmute you. So otherwise there will be a lot of noise. So I want to avoid those noise. So I want all of you to raise hands if you have a question. Yeah, so I can see Suhas has raised hands. You can unmute and ask.
Sir, you said about multiplying 2-digit numbers and 3-digit numbers, sir.
Yes.
Sir, then if regarding 2-digit numbers, if one number is greater than 100 and one number is less than 100, how can we multiply, sir?
So can you give an example of what multiplication you are trying? Give an example problem.
105 into 93, sir.
105 into 93. Okay. So this is what we classify as general multiplication. We have not learned about general multiplication. But if you're interested, there is a method called as vertically and crosswise. I'll write here vertically and crosswise. We will do it in the next class. So till that, you have to wait. You can do this very easily using vertically and crosswise. Otherwise, you can use one of the techniques that we have done. 105 times 93, right? So, okay, let me just erase that and put 93. So what you can do is you can take the same base rule that we have applied. So both of them are close to the base. What is the base? It is 100. So this is plus 5. What is the next number? Minus 7. So you can do the same technique. Here you will get minus 35. But minus 35, you can write it as a bar number like this. And the remaining is 105 minus 7 or 93 plus 5, which is 98. So this is going to be 9835 bar. Now you have to convert this as 98. This you can do by using alt from 9s, last from 10. So this becomes 9765 will be the answer. So we are applying the same rule except for the fact that now we have a bar number. Yeah. Suhas, I think your doubt is clear.
Yes, sir.
Okay. So are there more questions? You can raise hands if there are more questions. If you do not have any other questions, you can leave. I think Maunika was asking for the magic square. Okay, so before that, Santosh has raised hands. Maunika, could you raise hands so that I know that that question is pending? Okay. Santosh, what is your question? You can unmute yourself and ask. Santosh? Yeah, Santosh. I think Santosh is not replying. I'll give you one more chance. Okay, Santosh has lowered the hand. Maunika, I'll come back to your question. So can you ask the question once again? What specific part of the Vedic square you did not understand?
Sir, about Vedic square, I can't understand for third one.
Okay, so I will draw the Vedic square for you. So before that, again, Santosh, please wait till I answer this. Okay, so let me just try to take a blank side here. So I'll draw the Vedic square for you. So it is going to be a multiplication table, right? So the multiplication table is going to be the ones multiplication table. So Maunika, could you help me in filling in the multiplication table yourself? Maunika, once again, raise hands. I'll allow you to unmute. So by the time she has come, I'll write the multiplication table. Okay. So yeah, Maunika, please unmute yourself and help me with the multiplication table.
Okay, sir.
So what is the first row?
1, 2, 3, 4, 5, 6, 7, 8, 9.
Yes, that is the first row of the multiplication table. What is the second row? It is 2,
4, 6, 8, 10, 12, 16, 17, 16, 18,
no, 16. Okay.
14, 8,
Okay.
14, 16, 18.
So I'll write using commas so that you understand this numbers. Okay. What is the third row? This 3, 6,
6,
9.
9, 12, 15, 18, 21, 24, 27.
Correct. Okay, I'll write one more row. After that, we'll write down the Vedic square. Tell me one more row.
4, 8, 12, 16, 20, 24, 28, 32, 36.
36. Very good. So I have written 4 rows of the multiplication table. Now I'll write down the Vedic square for these 4 rows. Okay. So the first row, if you look, the digit sum you have to find. What is the digit sum of the first row? Can you say what is the digit sum?
First row, 1, 2, 3, 9.
1, 2, 3, 4, etc. up to 9, right?
Sir,
What is the digit sum of the second row?
2, 4, 6,
Yeah, go on. 8.
7, 8, 10, 12, 14, 16,
No.
18. Like
No,
that.
this is a digit sum that I'm asking. What is the digit sum of 10?
10, 5, sir.
No. What is digit sum? Okay. So digit sum is the sum of the digits, which is a number between 1 and 9, isn't it? So digit sum of 10 is 1 plus 0, which is 1. Is that
Okay,
clear?
sir. Yes,
Okay.
sir. Yes, sir.
Okay. So what is the digit sum of 12?
3,
And of 14?
5,
Very good. And 16?
7,
And 18?
9.
Very good. So you have to tell me the digit sum of the third row now.
Okay, sir. 3, 6, 9, 3,
Okay, very good.
9.
No,
Sir, 3, 6, 5 plus 1, 6 only, sir.
okay, 6. Yeah,
9,
okay,
3,
okay.
4 plus 2, 6,
Mm-hmm.
9.
Very good. And I want you to give the digit sum of last row as well.
Okay, sir. 4,
Hmm?
8, 3,
Hmm?
7,
Hmm?
2,
Okay,
6.
Okay.
8 plus 2, 10. So that one is not, I think.
Okay. So how do you do digit sum of 28? It
2
is 2 plus 8, which is 10.
10.
Now 10 is a number greater than 9. So again, you have to find the digit sum 1 plus 0.
1 plus 0, 1.
Yeah, so digit sum of 28 is 1.
3 plus 2, 6.
5.
5.
Yeah,
5. 6 plus 3, 9.
very good. So you have written down the digit sum of all these numbers. Now, if you write the digit sum of the multiplication table up to 9, you will get the entire Vedic square.
Okay, sir.
Now, the use of Vedic square is that you can identify or you can draw a lot of patterns using the Vedic square. Now, we have not talked about the application in more detail, so don't worry about that. But the entire idea of writing like this is to familiarize you with the topic of digit sum.
Okay, sir. Thank you.
Okay, yeah. So I want again somebody who has doubt to raise your hands so that I'll unmute you. Maunika, you can lower your hand. So I think there are no more questions. I'm looking the chat box as well. I think there are no more questions. So let us call this a day. So before leaving, you can go to this particular link. So if you have time, go to this particular link that is written here. You can give your response, how you are liking the class there. So I'll be able to know what is your response. So kindly take a minute for you to go to this link. I'll put that in the chat box as well for everyone. So you can kindly fill the response in that particular link. I'll have a look into that. So I think there are no more questions. So until we meet in the next class, let us call it a day. So thank you and namaste once again. So we'll end the session for today. Thank you one and all. Yeah, thank you all.
Bye, sir.
Yeah. Yeah, Hema Chandra Reddy, do you have a question?
When, sir, again next more class?
So next class is going to be on next Saturday.
Time?
Okay, thank you.